Good morning. We are presenting our project on parallel recurrent neural network. Our objective was to predict Apple stock prices using time series data. The main technical challenge is that RNNs are inherently sequential, making training very slow. We used high-performance computing to accelerate this process. We implemented the Vanilla RNN from scratch in C++. The network uses 32 hidden units with 10H activation and trains on many patches of 64 sequences. This gives us a solid baseline to compare with our parallel versions. To parallelize the training, we used OpenMP to distribute sequences across CPU cores. We used thread local storage to avoid race conditions and optimize synchronization to remove memory bottlenecks. As shown in our results, we achieved a significant speedup, and we confirmed mathematically parity, meaning the loss values are identical across all versions. We also developed a GPU version using CUDA kernels on an NVIDIA T4, while data transfer over header exists for small datasets. It proves the model's scalability on many core hardware. In conclusion, our parallel batching strategy is highly effective. In the future, we plan to extend this to distributed systems using API.
Now let's move on to the technical demonstration and walk through the command execution in the terminal. First, I'm setting up my environment, and then I'll do the compiling. So we have two versions. We have the parallel version and the serial one. So I'm compiling both of them from the root folder. So the 03 flag is to enable maximum optimization, and for the parallel version, I'm including the OpenMP flag to activate the multi-core processing. Now I will start with serial version. So as you can see, it processes the sequences one by one. It works well, but it takes about 1 second per window. So as for the loss, as expected, it increases slightly as the window size grows because longer sequences are more complex to predict. However, the error remains within a very small range, which shows the model is converging correctly. And since this is a vanilla RNN built from scratch for an HPC project, our focus was on achieving mathematical parity and speed up through parallel batching. So let's look for the parallel version. We'll run it. So we are using OpenMP to split the work between different CPU cores. You can see it's much faster. Most importantly, the loss is exactly the same as the serial version, which proves our parallel math is correct. It is the same. Now we will run this code, this file, to see or to compare the results. So here it is, our graph. Okay, so the gray bars are the serial time and the green bars are the parallel time. You can see that as the workload increases, our speed up gets much better, reaching 2.37 times faster. So this proves that our OpenMP strategy scales very well with larger sequences. Now I am showing our GPU implementation on Google Colab. We did it using CUDA. We used the NVCC compiler to run our code on an NVIDIA T4 GPU. And as you can see, we get the exact same loss, which proves our implementation is stable across all platforms. Thank you for your attention.